So in this video we're going to define and use the cross product. So the cross product definition is as follows. You take two vectors u and v. Both of those vectors need to be vectors in three-dimensional space, so vectors in 3 space. They have, in component form, they'd be u sub 1, u sub 2, u sub 3, v sub 1, v sub 2, v sub 3. And we define the cross product. So this is said u cross v, and the order of the cross product does matter. So u cross v is going to be defined as components u2 v3 minus u3 v2 times the vector I. Remember, I is just the vector 1 0 0, and then minus u1 times v3 minus u3 v1 times the vector j, where j is just that unit vector 0 1 0. And then it's going to be plus u1 times v2 minus u2 times v1 times the vector k, where k is just the vector 0 0 1. And of course, when you look at this, couple things to notice. One, we could write this kind of in an alternative form. If I wanted to distribute the minus sign into the parentheses, I could do a plusy right here, but I'd have to reverse the order of this subtraction. So that's an alternative way of writing it. The other thing to notice is that this would be probably a royal pain in your butt to have to memorize, but fortunately it actually comes straight from a determinant calculation, which is why we wasted the time to define the determinant in the previous video. So if we want to calculate u cross v, we'll get exactly this expression that we see up here at the right if we calculate this determinant right here. So this is first row contains the vectors I, j, k. The second row contains the components of the vector u, so the order matters, u1, u2, u3, and then the third row contains the components of the vector v. So if you walk through the determinant calculation, you'll see that you get exactly the expression that's sitting right here. It would be I times, and we would cross the row and column corresponding to I, and then we would take the determinant of this little minor matrix right here, u2 v3, there's the u2 v3 minus the other diagonal u3 v2, there it is, and then we would do minus j. We would do minus j times the determinant we get when we cross row 1 column 2, so we'd get u1 v3 right here minus u3 v1, and then it would be plus k, plus there's the plus k, and then we would cross the row and column corresponding to the element k and calculate the determinant of the minor matrix that goes with it. So it'd be u1 v2, u1 v2 minus u2 v1. There's the u2 v1. So the determinant calculation tends to be fairly easy to remember. So what we really need to remember isn't this expression here. We need to remember that, hey, to do u cross v, we just need to calculate this determinant. And then there's going to be a couple things that come out of this. One, we're going to discover that as long as u and v are non-zero and not parallel, then when we take the cross product of u and v, the result that we get, which we'll call the vector w, this result will be perpendicular to both the vector u and v. So we start off with two vectors u and v. We take the cross product, we wind up with the vector w that's perpendicular to both of those. And I'll probably take the time in another video to explain why that's the case. So cross product calculations are pretty straightforward then. If we want to do u cross v, this is just going to equal the determinant. We put I, j, and k, and then we take the components from u, and u has components 1, 2, negative 2, and we take the components from v, 1, negative 1, 2, 1, negative 1, 2, and we calculate this determinant. So we get I times, and then we take this little determinant right here, 2, negative 1, negative 2, 2, 2, negative 1, negative 2, 2, and then we do minus, and it's going to be minus j times the determinant. Again, we cross this and this, so it leaves us 1, 1, negative 2, 2, 1, 1, negative 2, 2, and then we do plus, and then it's k, times the determinant we get when we cross the row and column corresponding to k. So we get 1, 1, 2, negative 1, 1, 1, 2, negative 1. And then you just grind through the calculation. It's going to be I times 2 is 4, minus negative 2 times negative 1 is 2, minus j times 1 times 2 is 2, minus negative 2 times 1 is negative 2, plus k times 1 times negative 1 is negative 1, minus 2 times 1 is 2. And then simplify, we get I times 4 minus 2 is 2, so we get 2 times I, minus 2 minus negative 2 is 4, we get 4 times j, and we get k plus k times negative 1 minus 2 is negative 3, so we get minus a 3k. So ultimately when we do u cross v, we wind up with the vector result, and the result that we wind up with is the vector 2, comma, negative 4, comma, negative 3. And if you don't see immediately why that's the case, just replace the I with the vector 1, 0, 0. Replace the vector j with the vector 0, 1, 0. And replace the k with the vector 0, 0, 1. And then distribute and add. So we would get 2, 0, 0. Plus, distribute the minus 4 in, we get 0, minus 4, 0, and then distribute the minus 3 in, we get plus 0, 0, 3. And when we add these three vectors together, we're just going to get the vector 2, negative 4, negative 3. So that's our u cross v calculation. So I'm going to erase this mess here. I'm going to erase the calculation because I need some space. There's got to be a more efficient way to erase. So when we did this, we got the vector 2, negative 4, negative 3. So we want to do the calculation v cross u. And so this calculation is still going to be, it's going to be I, j, k. But now instead of u being row 2 and v being row 3, they're going to be reversed. The components of v will be in row 2, 1, 2, negative 2. Did that wrong. 1, negative 1, 2, 1, negative 1, 2, and it will be 1, 2, negative 2, 1, 2, negative 2. And then we would do this calculation, I times, we cross row 1 and column 1, we get negative 1, 2, 2, negative 2, minus k times, and we'd cross row 1, column 2, we'd get 1, 1, 2, negative 2, 1, 1, 2, negative 2, plus, and then we would get j times, cross, not j. That's supposed to be j. I don't know what I'm doing. I, j, k. And so for k, we would cross row 1, column 3, and we get this little minor matrix right there. 1, 1, negative 1, 2. I'm thinking ahead in my brain, and it's making me make mistakes. Don't like it when I do that. We get negative 1 times negative 2 is 2. Minus 2 times 2 is 4. Minus j times 1 times negative 2 is negative 2. Minus 2 times 1 is 2. And then we get plus k times 1 times 2 is 2. Minus negative 1 times 1 is negative 1. And we get the vector I times negative 2. 2 minus 4 is negative 2. I'm still in parentheses form. Minus j times minus 2 is minus 4. Plus k times 2 minus negative 1 is 3. And if we put this in the component form, we'll get negative 2. And this will be minus a negative will be a 4 right here. And then we'll have a 3 sitting here. And the reason for doing this calculation is to notice that the vector that we get when we reverse the order of the cross product is just the opposite of the vector we got when we did u cross v. Here I got I just killed it. We got 2, -4, -3, and now we have the vector -2, 4, 3. And in general, that's what's going to happen when you calculate, when you change the direction, the order of the cross product, you get the opposite vector. So if this is w, then this is, if we name this guy here w, then this guy is going to be the opposite of w. So we got the vector -2, 4, +3. And then the last thing that we want to do, just to drive home a particular point, let's say we cross u with itself. So let's say we do u cross u. And we're going to get the determinant calculation I, j, k. And if we cross u with itself, we just take the components of u and put it in both row 2 and row 3. So 1, 2, -2. And if we do this calculation, we'll get I times, it'll be 2 times -2 is -4, minus -2 times 2 is -4, plus we'll get a minus k times, so I don't know why I keep putting k there. It's j, I, j, k. I can't even do the alphabet today. So we cross this row and this column, we're going to get 1 times -2 is -2, minus -2 times 1 is -2, and then we're going to get plus k, I, j, k. So we're crossing row 1, column 3. We get 2 times 1 minus 1 times 2 is 2 minus 2. And what you'll notice here is we're getting I times 0 minus j times 0 plus k times 0 is just the 0 vector. And in general, this is what's going to happen. If you take the cross product of two parallel vectors, you're going to get the 0 vector popping out of it. Any vectors that are parallel, and of course u is parallel to itself, so it kind of epitomizes the idea of being parallel. So calculation of a cross product, very simple. It's going to turn out to be very useful, we'll see as we get into finding equations of planes in 3-dimensional space.